Sorry about that. Just making sure the screen was working. Ladies and gentlemen, we're going to do a quick activity. Need a piece of paper with your name on it. This should look somewhat familiar on the left side, I hope. And I'm trying to move it a little bit, so maybe it looks a little more. Oh, it looks good now. Get my face out of the way. Give a complete balanced combustion reaction for the burning of limonene. Good. And then I had these two amounts of chemicals that would react. Limonene is the fuel, right? Fuel. And O2 is the other reactant. Yeah. And then looking ahead is why we're doing this. Whichever answer B or C. So if I mix this amount with this amount of these two chemicals, I want to know what's the most CO2 I can make. That's what this said. All right. So the wording in 141, this whole page is going to be like a sentence with 3 or 4 lines in it. And we have to be ready for that, right? Copy what is written below. So your activity starts right here, if I can get it. Well, it's on the middle of the page, but it's going to be moved over here, okay? So, when 4.243 grams of limonene is reacted with 10.12 grams of oxygen in a combustion reaction, comma. I got to go down on the screen if it lets me. Good. I need this number. 8.163 grams of carbon dioxide is formed. 8.163 grams of carbon dioxide is formed. Calculate the percent yield. That's it. Wow. Okay. And we'll make it nice and big. And we like purple. And we'll make it fit to the underneath over here. Kind of squish it a little bit and move it over. There we go. So that one little sentence is this whole page from your test. Is there a typo? Let's fix it. Limonene is reacted with 10.12 grams of oxygen. Or, thank you, sir. Of limonene is reacted with 10.12 grams of oxygen in combustion reaction. Yeah, if I fix that a little bit, get the G, there it is formed. I don't even use the words actually formed, did I? No, they won't be doing that in 141 either. So we're gonna do a pause and then we'll come back on this, okay? So, continuing our video, we are looking at a problem we did on our exam on Monday. And this is the Chem 141 translation of the same whole page, right there. The steps are listed to the left. So we need a complete balanced combustion reaction for the burning of limonene. Limonene being C10H16. I hope this was not a surprise to see this question on the test. Didn't ask for states, did it? It's a combustion reaction. What is the other reactant? I need its formula. Oh no. Yeah. If you put CO2 in there, you put out the fire. CO2 is a product of the fire. And what's the other product of the fire? H2O. And I picked a pretty straightforward one in terms of balancing, didn't I? 10 CO2s and 8 H2Os give 16 H's and 20 O's, 10 C's, right? Now you can do oxygen. That's 20 plus 8 equals 28. How do you get 28 out of this? 14 times 2 is 28. Done. If 4.23 grams of limonene completely reacts, what is the theoretical yield of carbon dioxide in moles? I'm just reading from here. It's even got steps for our steps. Mouse issue here, sorry about that. I'm sorry? No, you don't have to write anything. It's not an activity yet. I may pick something from the left side and tell you to write it, but we're not there yet. So we're just paying attention. And now we're going to say grams. You can't use grams in a balanced chemical equation. What are these things called again? The 1 here, the 14 here, the 10 here, and the 8 here. What are they called? Coefficients. What's the only thing they're good for? Moles of A to moles of B. You better get to moles first. It even reminds you right over here. You will not be reminded to go to moles in Chem 141. 4.243 grams. We're going to need a formula weight, right? FW is going to be 10, not 18, 10 times 12.01 plus 16 times 1.008. And somebody's going to work that out for me. And I'm going to set up the next part. 4.243 grams times 1 mole of stuff for every how many grams? Have you worked it out yet for me? 136.228 grams. And now work that one out for me. 4 times 25 gets close to 100. And 1 over 25. 0.03114631. And that's mole. And with the theoretical yield in moles. So 4 sig figs would give us mole. We need another formula weight. This one, I don't need to wait for you. Formula weight of oxygen. Now, when I say oxygen, you know that's O2, right? 2 times 16.00 equals 32.00 grams per mole. Oh, yeah. And I forgot to write down her answer up here, 136.228. I'm sorry, say it again. Oh, we didn't finish the question is what she was correctly saying. We figured out the moles of limonene. That's all we did, right? Once again, this has happened before when I didn't write down what the moles were for. I didn't have that to remind me I wasn't finished. I'm just telling you guys, not writing things by just being lazy will cost you points because you're going to miss a step. And I'm getting mad at you. I did the mistake. I'm not mad at you. I'm mad at me. That was moles of, I think the fastest way to say it, C10H16, right? C10H16. Well, we should do it here, right? C10H16. And then I'm going to do a conversion to get rid of C10H16. Mole C10H16. And we're talking about what is the theoretical yield of carbon dioxide? I need moles of CO2. Hey, that's a relationship between moles of substance A and moles of substance B right there. Where do I get the numbers? Coefficient. CO2 has a big 10 in front. C2H16 has a 1 in front. So my final answer is 0.3115 after rounding. Mole CO2. This is mole C10H16. Why it keeps changing? Oh, those are Christmas colors. That's right. There we go. And that one, this one's mole CO2. Here's your coefficients. OF. There you go. Okay. And we'll do the same thing in the next one. Maybe sneak it in to the left of the box. We got 10.12 grams O2. Write down what it is. 1 mole for 32 grams grams of O2 times, this is O2. Got to get rid of O2. Introduce moles CO2. Hey, moles A, moles B. You get 10 moles CO2 if you burn how many moles of O2? 14. Nice job. And that's going to give us a final answer of, somebody can work it out for me. 1 over 32 is like 0.3, 30 over 14. It's like 2-ish, right? Sorry, say it again. That's 10.12. Yeah, like right above it in the question. 0.22. 589. 2856. Moles CO2. 0.2259 moles CO2. Final answers. Highlighter. We're comparing that number to this number. Yeah. Wow. Let's make sure this is good though. That's 0.3. 30 over 0.3, that becomes like 3 over 14 is about a little under a third. Yeah, it makes sense. Does make sense. Does this one make sense? Oh, that's my final. I shouldn't have highlighted that thing over there. The two things you're highlighting are, if you react all of the C10H16, this is how much CO2 you can make. If you react all of the O2, this is the amount of CO2 you can make. If you mix this with this, what is the most CO2 you can make? That's what's called the theoretical yield from the, here's the new stuff, the limiting reactant. I'm sure you've seen it, you just didn't study it because you knew it wasn't on the test yet. Limiting reactant is the one that runs out. Hey, guess how much reaction happens after one of the chemicals runs out? None. 0. Game over. So if anybody tries to tell me it's at all possible to make 0.3115 moles of CO2, then you're living in an alternate universe. Because after you made 0.2259 moles of CO2, this oxygen is gone. You can't react oxygen if you don't have oxygen. So when you're figuring out theoretical yield of CO2, you got to use both reactants, figure out how much CO2 each one makes, pick the lower number. So which one of those is the lower number? That. This is the theoretical yield and because it came from O2 is the, and what's that word for the reactant that runs out? It's 2 words. Limiting reactant. So the process is pretty straightforward, but there's a lot of steps. Balanced chemical equation. Go to moles for each of your reactants. Convert it to moles of the product that they're asking about in the question. I was asking about CO2, wasn't I? Yeah. And then the lower of those 2 numbers is the one that's going to tell you your theoretical yield. So that number, and I told you to do that right here. Whichever of B or C is smaller, that is the smaller one, is the real theoretical yield, because it comes from the limiting reactant. The other one, do you happen to know the name of the other reactant? So theoretical yield from this is the theoretical yield, and it gives us the limiting reactant, and it tells us the other one is, it's there in a overabundance. We could call it the overabundance reactant, but we don't. What is the word we use? You've got more than you need. Excess reactant. but please follow the arrows for the logic. You determine which of the numbers is smaller to tell you the theoretical yield. That also tells you, going backwards, that O2 ran out first. It's called the limiting reactant. The limiting reactant, and the other reactant's called excess. This number is useless. Which is a little, that's a little too simply stated. We needed to figure it out to figure out that it was bigger than the other one. But now, after we've done that, you will never use that number because you live in a real universe, not an imaginary one, okay? Where you can react more than you have. No, we don't do that here, okay? So we got the real theoretical yield right there, and it says, convert the real theoretical yield to grams. So we're gonna need a formula weight for the chemical we're talking about, CO2, 12.01 plus 2 times 16.00, 40, 12 plus 32 is 44.01 grams per mole. He's going to stop asking what are the units on the periodic table now. He assumes you know. Okay. So I'm going to convert that square box 0.2259 moles CO2, something that gets rid of mole CO2, gives me grams CO2. It's written right above, 44.01. No activity for this, so don't stress out, guys. And then it's a little, about a quarter of 44, a little less. I'm saying it's close to 10. 9.941859. Close enough. And that would be grams CO2, right? And it's not a final answer, so you don't even round it. Oh, it is a final answer. It says convert the real theoretical yield to grams. So final answer, 4 sig figs. And I'll give you a little heads up about a personal preference I have about sig figs. Once I get you using the periodic table, it's pretty much just give me 4 sig figs if you can. Okay? Because everything on there is 4, and I think it's a good number. And we know sig figs. One last thing to worry about. When in doubt, if anytime you use that thing, 4 sig figs, you probably won't lose any points ever. As long as you're using the periodic table. Got it? And then 8.163 grams is actually produced. Oh, this is the easy part, right? Percent yield, you take your actual, which was 8.163. It even says actual over what you could have got, theoretical, times 100, and it's pretty good. It's not an A though. Looks like a high B. And while you're doing that, I'm going to write down the conversion factor for the last one. 6.02 times 10 to 022, 10 to 23rd molecules per mole. And the answer you're giving me, I don't need the answer you're giving me. I'm going to go with the moles, which was 0.2259 moles. And she's going to give me her answer from the previous one. Sorry to jump around like that. It's close to 90. Oh, 82. Just give me 2 more sig figs. 106. So 11. And this one you're going to work out for me too. Quarter. It looks like 3 times 10 is 23. Is that right? No, it can't be that. No, third. 2. Close to 2. Am I that off? I don't know. Yeah, I wasn't terribly close. 1.3603. Close enough? 8. Any more? Yeah. Now, if you're writing this on your test, I got to tell you, you see this on your calculator and you write this, some of you are going to groan right now. I'm taking a point off. You just said it's 1.360368 raised to the power of 23. Incorrect. You got to know when it looks like that on your calculator, what you're supposed to write down on the exam. And it's times 10 to the power of 23. And that was the right exponent, right? And 4 sig figs, 0 times 10 to the 23 molecules. So that little bit of fuel made a whole bunch of molecules of CO2. And the big picture, this is a prep course for Chem 141. This translation is for your whole page on your exam. Be ready for this in your next course, because that's how they're going to ask the same question. And they're going to expect you to do it all semester. And guys, you're going to get another one like this next test. That's why on the board I wrote down, this never goes away. Grams to moles of one substance, to moles of another substance with the coefficients, to grams of the other substance. Okay? Never goes away. How do I do that? Get it on the next test and still relevant? Well, when we start solutions, and you guys have been doing solutions all semester in the lab, we're going to start with something called molarity. And I'm going to start giving you volumes of solutions. And from volumes and molarity, you're going to learn, you get moles, and then you're back to this game. This big game right here. Long video, but I hope it gets you a little motivated for Chem 141.